What we are going to look at now is finding the equation of a straight line if we are not given the y-intercept. And if that's the case, we can utilise this formula. Y minus b equals m bracket x minus a. This will not be given in your exam. So this is something you do need to absolutely remember, because this is very examinable. It comes up almost every year. Y minus b equals m bracket x minus a. M stands for the gradient, and AB is a point that is given on the line. So the gradient could be 5, and these 2 points here could be 4, 2. Okay, and we would substitute these values into our equation and have it in the form of a straight line. So it's just best to have a look at this with a few examples. Okay, let's imagine we were given a problem where it tells us that the gradient is 4 and the line passes through the point 3, 5. So we're not told what the y-intercept is, so we can use the formula y minus b equals m bracket x minus a. So we obviously know what m is. M is going to be 4, but to get the points a and b, what we have to do is we just need to label these points here. Label the points a and b. What we're now going to do is we're going to substitute all this information into this formula here. So y minus b, so it's going to be y take away 5, because b is 5, equals 4, because our gradient is 4, x minus 3. That is us completed it in its most simple sense, but we still need to tidy it up. We need to make it look a bit neater. So what we're going to do is we're going to multiply out this bracket. So we're going to have y minus 5 equals 4 times x is 4x. 4 times minus 3 is minus 12. And if we think back to our general form of a straight line, it's y equals mx plus c. So I just want to have y on the left hand side. So I want to get rid of this minus 5. So I'm going to add it to both sides. And that will give me the equation of the form y equals 4x minus 7. Okay, so from this, I can now state what the gradient is and what the intercept is. But the most important thing is that you can input all this information into this expression and then work through. Okay, here we've got a line that has a gradient of minus 6 and it passes through the point minus 2, minus 3. So write down my formula, y minus b equals m bracket x minus a. I need to label my points. This is a and this is b. So I'm doing y take away b. So y take away b is minus 3. So it's y take away minus 3 equals minus 6, because minus 6 is my gradient, and it's x take away negative 2. So here we've just got to watch out for our negatives. My next line, I'm just going to tidy it up. I'm just going to make it simpler. So y plus 3 equals minus 6 x plus 2. When you take away a negative, it's the same as adding. I am now going to multiply out my bracket right here. So I'm going to have y plus 3 minus 6 times x is minus 6x, minus 6 times 2 is minus 12. I want to have it in the form y equals mx plus c, so I want to get rid of this plus 3 on the left hand side. So I'm going to subtract it from both sides, which will leave me with the equation in the form y equals minus 6x subtract 15. Okay, in this last example I've been given the gradient is 2/9 and the point that it goes through is 5 minus 2. So I am going to need to substitute this all into the formula y minus b equals m bracket x minus a. You need to remember that formula. Okay, so I'm going to label my points a and b. So y take away minus 2 equals 2/9 x take away 5. So I've just substituted everything in. And my next line, I'm just going to tidy up this left hand side. When you take away a negative, it's the same as adding. 2 ninths x take away 5 in your brackets. So, there's a few options here. We could multiply out the bracket on the right hand side as normal, but we're going to get fractions, and although fractions are fine to work with, they can get a wee bit messy at times. So we are going to almost like do a wee trick to get around this. If we think back just to like a regular question, let's imagine the question was x divided by 3 equals 10. Imagine we had this question. To find out what x is, you would multiply both sides by 3. So I would times this side by 3, and I would times this side by 3, and I would have x equals 10. Oh, sorry, x equals 30. Okay, by multiplying both sides by 3, I'm almost cancelling down the 3's on the left hand side. So if we apply the same sort of thinking to our expression here, if I want to get rid of the 9 at the bottom of the fraction, what I can do is I can multiply everything in this expression by 9. So I can multiply the right hand side by 9, and I can multiply the left hand side by 9. But we're going to multiply both expressions by 9 here. By doing so, it allows me to write my equation in the form 9y, 9 2's are 18, so 9y plus 18 equals, these 9's would cancel away, these would disappear, so I'll just have 2x minus 5. Then what we need to do is we would need to multiply out our bracket. So 9y plus 18 equals 2x minus 10. So 9y plus 18 equals 2x. We want to have our equation in the form y equals mx plus c. So here we've got 9y plus 18, so we don't want to have this plus 18 here, so I want to get rid of it, so I'm going to take it away from both sides. I'm going to have 9y equals 2x minus 28, and to get 9, or to get y equals, I'm going to divide both sides by 9. So y equals 2 ninths x minus 28 ninths. So when you have a fraction as a gradient, you need to multiply both sides by the denominator of the fraction.